it's Mrs. Lindquist. Today we're going to be talking about the law of cosines. So just to refresh your memory, the law of sines says the sine of angle A divided by little a, which is its opposite side, is equal or congruent to the ratio sine of angle B over little b, which is congruent to sine of angle C over little c. So you cannot use the law of sines unless you have a side and its opposite angle. So another formula is needed if you do not have a side and its opposite angle. And that leads us into the law of cosines. So I'm going to write out here, we have a squared, little a squared, equals b squared plus c squared minus 2bc times the cosine of angle A. So what you're going to notice here is little a squared and cosine of A, those should be on opposite ends of the equation. We could write a similar equation, b squared equals the other two sides squared, a squared plus c squared minus 2ac, which are those two right there, times the cosine of angle B. Since this is b squared, this would be the cosine of angle B. And then likewise, we could do the last one. So if you look at this last one here, it does kind of look like Pythagorean theorem, except for we're subtracting out the 2ab times cosine c. So I guess the biggest thing to remember here is whatever this angle is, this side on the other side of the equation is the opposite side. So these are three equivalent forms of the law of cosines, and we're going to use these equations to solve for missing sides and missing angles of triangles. Example 1. Use the law of cosines, round to the nearest tenth. And this is a missing side length problem. So it says the lengths of two sides of a triangle are 8 centimeters and 10 centimeters, and the measure of the angle between them is 40 degrees. So I always find it helpful to draw myself a picture. So we have maybe this side is the 8 centimeters, this one maybe the 10 centimeters, and obviously this is not drawn to scale, but the angle between them is the 40 degrees. And then it says find the length of the third side. So we want to find the side opposite of 40 degrees. So when we set up our equation, remember we talked about on the left side of the equation, we want to have the side that's opposite of the angle measure that we know. So we're going to have x squared equals the sum of the other two sides squared. So 8 squared plus 10 squared minus 2 times 8 times 10 times the cosine of 40 degrees. So it's important that the side length x is the side across from 40 degrees. So when you set this up, just remember whatever angle measure you put here for the cosine, on the other side of the equation should be the opposite side. So now we can go through and solve this out. So we're going to have x squared is 64 plus 100 minus 160 cosine 40. So we can actually do this sum here. So we have 164 minus 160 times the cosine of 40 degrees. Again, when you put this in your calculator, make sure you are in degree mode since you're doing cosine of a degree measure. So we're going to get x squared is about 41.4. So then we're going to take the inverse and we're going to square root both sides. And we're going to have x is approximately, normally we would have positive and negative 6.4, but since this is the side length of a triangle, we would say that x is approximately 6.4 centimeters. And there you have it. Okay, so in example 2, we're going to be looking at using the law of cosines to find a missing angle. So in triangle ABC, so let's just label this out. Angle A, angle B, angle C. Little a is 5. So the side across from angle A is going to be 5. Little b is 8, and little c is 12. So in this particular triangle, we know all the sides, but none of the angles. And they want us to find the measure of angle C. So since angle C is the one we want to know, we are going to start our equation off with the side opposite of angle C, which is the 12. So we are going to have 12 squared equals the sum of the other two sides squared. So we're going to have 8 squared plus 5 squared minus 2 times 8 times 5 times the cosine of angle C, which we're trying to find. Okay, so let's simplify this out. So we'll have 144 is equal to 64 plus 25 minus 80 cosine of angle C. So now we're going to subtract off the 89 off both sides of our equation. And again, we're trying to solve for cosine of C, so we're going to divide both sides by negative 80. We're going to get negative 0.6875, approximately equal to cosine of C. And again, you probably want to leave all these digits in there so that when you are solving for angle C and doing the inverse, you're going to do cosine inverse of the negative 0.6875. Again, leave those digits in there. You can press second answer. That will leave it so it's not rounded. And so we're going to finally end up with angle C is approximately equal to 133.4 degrees. And there you go. Okay, so our last example, this one's a little bit more challenging. So let's just kind of label our triangle ABC and label what we have. So we have a side, angle, side, and they want the measure of angle B. So right now we can't use the law of cosines because in order to use the law of cosines, we know the side across from our missing angle, but we don't know the other two sides that include the angle. So law of cosines is going to be out to find this angle, but we could use law of cosine since we know this angle and these two sides. We can use the law of cosines to find this side. So I guess we're going to start off with finding this side. So we're going to have x squared equals. Okay, so if we put all of this into our calculator, again, making sure that we are in degree mode, we're going to get approximately 30.889, and we'll do an inverse. So x is approximately 5.6. So once we know x is about 5.6, we'll just label that in here. Now we're looking to find angle B. So yes, we do have enough information that we could do a cosine problem at this point. But if you think about it, we actually also have enough information that we could do a sine problem, since we know this angle and the side across from it, and we want to know this angle and we already know the sine across from it. So for me personally, I like to use the law of sines. So I'm going to do the sine of 45 degrees over its opposite side of 5.6 is equal to sine of angle B that I don't know divided by 6.2. And again, you don't have to do law of sines. You could do a law of cosines, a second law of cosines problem. But again, I just find this to be easier. So we'll do our cross multiply. And we're going to divide both sides by the 5.6. So sine of angle B is going to be approximately 0.783. And again, make sure if your calculator gives you a parenthesis that you close the parenthesis off before you divide by 5.6. So to get angle B, we're going to do the sine inverse of 0.783. And again, if you have extra digits, it's best to leave those in there. So angle B is approximately 51.5 degrees. And again, if you're doing a missing angle, make sure you have the degree symbol. So we saw in this problem, it was multi-step. We had to do a law of cosines, and then we had to either do a law of sine or a second law of cosine problem in order to find this angle. So sometimes you need to find what you're able to find, and then hopefully that information will help you find what you are really looking for. Okay, well that's a wrap on the law of cosines. Have a great day, guys. Bye.